Welcome to Skyscope, the podcast for amateur astronomers who want more than just the obvious. Each week, we highlight one carefully selected target, from faint planetary nebulae to off-the-path galaxies designed to push your skills, your optics, and your curiosity just a little further. Today, for calendar week 29, we're turning our gaze towards one of the summer sky's most iconic and intriguing objects, Messier 57, the magnificent Ring Nebula in the constellation Lyra. Get ready to truly challenge your observing skills.
This is Skyscope, challenging targets, real observing.
So M57 has this really rich history. Discovered by chance, mistaken for stars, revealed as gas, finally photographed. It's quite a journey. But why this nebula? Why has M57 become such a superstar for amateur astronomers?
Oh, it absolutely is a superstar. It's easily one of the best known deep sky objects, especially in the summer sky. For a lot of beginners, it's one of the first nebulae they target because, frankly, it's pretty easy to find.
Right.
But even experienced observers keep coming back to it. There's always more detail to try and tease out, especially with bigger scopes or better conditions. It really grows with you.
And that shape, that classic smoke ring look, is visible even in pretty small telescopes, isn't it? That's a big plus.
That's a huge part of its appeal, yes.
Yeah.
It's not just some faint, nondescript fuzzball. It actually looks like something. You can recognize it instantly.
Yeah, it's got character.
Definitely. And like you said, finding it is straightforward. You find Vega, then drop down to Chiliac and Sulafat in Lyra.
The stars that form that little parallelogram shape.
That's them. And M57 is sitting right there between Chiliac and Sulafat. Pretty simple star hop.
So easy to find, iconic shape. And it's also a sort of benchmark object, isn't it? Like a classic example of a planetary nebula.
It is. It's considered a prototype. And interestingly, it's one of only 4 planetary nebulae in Messier's entire catalog.
Only 4. What are the others?
M27, the Dumbbell Nebula, M76, the Little Dumbbell, and M97, the Owl Nebula. So M57 is in pretty select company in that list.
Okay, so for observers taking notes, what are the key stats we should jot down, the vital details for our log?
For your observing log, its apparent brightness is magnitude 8.8. Visually, that's quite bright for a nebula, which is great.
Makes it easier to spot.
Definitely. And its apparent size on the sky is about 80 by 60 arc seconds, or roughly 1.4 by 1.0 arc minute. So fairly compact, but large enough to show that ring shape.
Okay, and what about its distance? How far away is this thing?
That's actually a good example of how science refines things over time. For years, estimates were around, say, 2,000 to 2,300 light years.
Okay.
But more recently, using super precise data from the Gaia satellite refined in 2021, we now think it's closer to 2,570 light years away.
Wow, so a bit further than we thought, about 790 parsecs.
Exactly. It just shows how our measurements get better and better. Our picture of the cosmos is constantly being updated.
That's cool. So at that distance, how big is it actually? In light years?
Its true physical diameter is somewhere between maybe 0.9 and 1.3 light years across. So, roughly a light year wide.
A light year, that's vast. And how old is it? When did the structure form?
The age estimates vary a bit. Some lower estimates put the nebula's age, the time since the gas started expanding, at around 10,000 years. The newer studies, using Hubble data from 2013, suggest it might be younger, maybe only about 4,000 years old in terms of the main shell expansion.
Huh. Only 4,000 years. That's relatively young in cosmic terms.
It is. Though it's worth remembering, the star itself started shedding its outer layers much earlier, maybe 20,000 years ago. So the process has been going on for a while.
Okay, so we see this ring shape, but you mentioned earlier that it's kind of an illusion based on how we see it. What's its real shape in 3D?
That's a great point. The ring is what we see because M57 is actually what we call a bipolar nebula.
Bipolar, meaning 2 poles.
Exactly. Think of it shaped more like an hourglass, or maybe a cylinder that's pinched in the middle, with 2 lobes of gas expanding outwards from the center.
Okay, like a dumbbell or an hourglass.
Right. And from our viewpoint here on Earth, we happen to be looking almost directly down the axis of that hourglass structure. It's tilted maybe 30 degrees relative to us.
So we're looking down the throat of the hourglass, and the edge of that opening looks like a ring.
You got it. That bright ring we see is really the denser material concentrated around the equator, the waist of the hourglass, seen from that angle. That bright inner ring isn't the whole story. It's actually surrounded by a much fainter inner halo of gas.
Okay.
And then an even fainter, much larger outer halo. This outer halo is huge, about 3.8 arc-minutes across.
Nearly 4 arc-minutes. It's way bigger than the bright ring.
Much bigger, and incredibly faint. It wasn't even discovered until 1935 by John Charles Duncan. You really only see it in deep, long exposure photographs. It's far too faint for typical visual observation.
So what kind of star is it now? What's left after it puffed off all that gas?
It started life as a star, pretty similar to our sun. It ran out of hydrogen fuel in its core, swelled up into a red giant, went through the asymptotic giant branch phase.
Okay.
And then about maybe 6,000 to 8,000 years ago, it ejected those outer layers. That's the gas shell we see as the nebula. What's left behind is the star's core. It's now a white dwarf. Extremely dense, composed mostly of carbon and oxygen with just a thin skin of lighter elements.
A white dwarf. Who first spotted it? Was it known early on?
The central star itself was first visually detected by a German amateur, Friedrich von Hahn, way back in 1800. And then Jenna Gothard photographed it in 1886 along with the nebula. Interestingly, there have been reports over the years of its brightness varying visually, maybe between magnitude 14.2 and 16.
So it might be a variable star.
It's suspected it might be irregularly variable, yeah. Though some of that variation might just be difficulty in measuring it against the bright nebula background. And here's something really cool in recent observations with the James Webb Space Telescope, JWST, just in 2024. They actually found evidence of a dust disk around the central star, and hints that it might even be a binary system.
A binary. So there might be another star orbiting it.
Possibly. A close companion could definitely help explain that bipolar hourglass shape of the nebula. It adds another layer of complexity.
Okay, now for the moment you've been waiting for. How can you listening observe this magnificent object this week? This is your Skyscope challenge for calendar week 29. First off, the best time to look is during the summer and autumn months when Lyra is nice and high in the sky. Now finding it. First step, find Vega. Super bright star, part of the summer triangle, can't miss it in Lyra. Then look just south of Vega for 2 other moderately bright stars, Chiliac, that's Beta Lyrae, and Sulfat, Gamma Lyrae. They make a little parallelogram with Vega.
Right. And M57 is located almost exactly between Chiliac and Sulfat, about 40% of the way along the line connecting them, maybe slightly closer to Chiliac.
Okay, so we found it. What can we actually expect to see depending on our gear? Let's start small. Say, standard 10 by 50 binoculars.
With 10 by 50s, honestly, it's tough. M57 will likely just look like a faint 9th magnitude star. Very hard to distinguish it from the actual stars around it. Maybe just a point of light.
Not much detail there. What about slightly larger binoculars, like 16 by 70s? Any better?
A little bit. With 16 by 70s, you might notice the M57 looks slightly different. Maybe a bit fuzzy or not quite a perfect pinpoint like the other stars. That can help you pick it out. Still no ring shape, though.
Right. Now, moving up to a small telescope. A small refractor, maybe 2 or 3 inches, like 7.5 centimeters.
Now we're talking. With a small refractor, maybe around 30x magnification, you'll definitely start to see it as a small, fuzzy disk, almost round. And the nice thing is you can often spot it even from suburban skies with moderate light pollution, or even when the moon is out, although darker skies are always better.
Okay, so a small scope reveals the disk. Now, what about medium-sized telescopes, say a 4 or 5 inch 10-centimeter aperture? This is where the magic starts, right?
This is where it really starts to look like the Ring Nebula. Push the magnification up to maybe 100x or so. You'll clearly see the smoke ring shape emerge. You'll notice it's not perfectly round, but slightly elliptical, hinting at that 3D structure we talked about.
The oval shape.
Exactly. And under good conditions, look closely. You might start to see that the ring isn't uniformly bright. It often looks a bit brighter on the northwest and southeast sides. The central hole, the donut hole, will also become obvious, clearly darker than the ring.
And while we're in the area, you mentioned something else nearby, a galaxy.
That's right. Just about 4 arc-minutes northwest of M57, so very close in the field of view, lies a faint galaxy called IC1296.
IC1296. How faint is it?
It's faint, about magnitude 14.4, and it's a barred spiral galaxy. Visually, you'll likely need a large scope, maybe 10 inches or more, and dark skies to even pick it up as a faint smudge. It's much easier in photographs.
Okay, a challenge object itself.
It is, but the really mind-bending thing is its distance. IC1296 is estimated to be around 230 million light-years away.
Whoa. compared to M57 at only about 2,500 light years.
Exactly. It's just a distant background object, completely unrelated to the Ring Nebula, happening to lie along the same line of sight. It really hammers home the scale of the universe when you see them near each other in the eyepiece.
That's incredible. A foreground planetary nebula and a background galaxy millions of times further away, almost side by side visually. The Ring Nebula truly is a masterpiece of the night sky, offering a rewarding challenge for every astronomer, no matter your experience level. Its history, its surprising structure, the science behind its glow.
Yeah.
It just makes observing it so much richer.
And that makes you wonder, doesn't it? Beyond these famous sights, what other amazing, maybe fainter or more challenging objects are out there waiting for us? What other hidden gems are just beyond the obvious, if we just know where to look and what techniques to use?
Absolutely. The universe is full of wonders. If you enjoy this episode of Skyscope and you're hungry for more challenging, beautiful, and off-the-beaten-path objects in the night sky, make sure to subscribe to our channel. By subscribing, you won't miss a single target, tip, or opportunity to take your observing to the next level. Thanks for listening, and until next time, clear skies.
And steady scene.
Skyscope. Challenging targets, real observing.
Subscribe to our YouTube channel for weekly podcasts and more.